MEDINI City. MEDINI is a new urban township with an integrated and comprehensive master plan coordinated by MEDINI Iskandar Malaysia. The master plan is designed with a strategic vision to encapsulate MEDINI as a city that is strong and iconic with distinctive new building design and people-oriented public space. 351 acres of land consist of Zone B, which is planned business and media district area. Its core use is targeted for commercial center, SME business park, hotel, and hospitality. This 2.3-acre proposed site was located near to the water body, which improved the value of the site, with its existing 3-meter slope was owned by Majlis Bandaraya Iskandar Puteri. In conjunction to the vision of Smart Iskandar Puteri is to ultimately produce a smart, sustainable community where residents, investors, and visitors are able to experience a place that is uniquely livable, connected, efficient, and safe. The goal is to deliver smart solutions to low-energy building through implementation of integrated shading device for Soho building in tropical climate conditions. Regardless to high dependency of Malaysia on fossil fuels, the importance of using renewable energy is highlighted as solar was a free source that available for utilization. However, lack of awareness and understanding of PV technology caused ignorance towards its added value and adverse public perception on PV technology due to its poor image of the standalone system and the cost of PV installation itself. The first objective of this research was to design and experiment the photovoltaic shading device for optimum energy efficiency performance. According to research done by Karimi, its orientation is the most effective orientation to connect solar energy in tropical climate, followed by west orientation. The effective tilt angle of its orientation was 30 degrees, while west orientation is 60 degrees. Thus, 6 photovoltaic panels were designed and being experimented, and design 6 was chosen due to its high performance. Simply design increased the performance of photovoltaic better. The overhang of the panel worked as shading to the interior with enough daylight factor for 6 working space. It was shown in the simulation results. In order to test the photovoltaic efficiency, energy wattage usage was calculated to find how much energy needed by the unit versus how much the energy produced by the panel. Unit A required 36.1 kWh per day, while Unit B required 31.3 kWh per day, and C needed 37.8 kWh per day. By using the formula, it shows that the panel managed to produce up to 41.5 kWh per meter squared a day. It is enough to sustain the need of every Soho unit energy demand. The excess energy will be stored into storage bank on the basement level and recycled to be used into another part of the building. Move on to the second objective is to propose PVSD system in order to achieve low energy usage in Soho building. This self-sustained Soho building was a joint venture between Iskandar Investment and SEDA, which is Centre of Entrepreneur Development and Research, who aspired to be the Centre of Excellence for Entrepreneur Development and Transformation by providing business coaching, business pitching, and communal activities through engagement. Thus, to achieve the goal, the building is designed to be elevated to create a new public places as a sense of welcoming to increase local participation. The arrangement of the spaces are in vertical form, where the private area are located higher so that the privacy are controlled, and more importantly, the building orientation, the longest facade of the building are facing east and west as to maximize sun penetration for photovoltaic panel. Apart from that, the intention is to maximizing the view towards the Viridea lake, as well as the intention of borders building are implemented to create a high permeability in the building. Car park for the building is proposed to be underground so that ground floor can be celebrate public user. Basic building development is started with site surface as a guidance for the block, then being dissecting into 2 spirited blocks. The longest facade are facing east and west as to maximize sun penetration for photovoltaic. The blocks are lifted as a sense of welcoming and allow public access on the ground. The blocks are tilted according to sun angle on December and June to maximize sun penetration throughout the year. The blocks are stacked slanted to maximize sun penetration on outside, but the inside will create passive shading on the courtyard. The building was developed from the simulation result of massive simulation for having the longest facade on east and west. Simulation 3 showed the highest cumulative solar radiation collected among the rest. Thus, design simulation 3 was selected and developed into further stage. As the ground floor shows, the openness of the area is celebrating public user. It allows public participation on ground floor, which having meeting space, public lounge, cafe, and open courtyard to easily escape into lush greens and fresh air. Moving to first floor level, it was commercial lot of shopping retail area, cafes and food courts, while second floor was a semi-public area for entrepreneur development, mentoring class, office and library. MEDINI Soho was starts on third floor level, which becoming the epicenter of entrepreneur, community and modern lifestyle. Every floor was accommodated with shared communal space for outdoor meeting and relaxing accompanying with lush green landscape for fresh air. Every floor was cascade 1 meter from each level to increase the efficiency of the photovoltaic panel, as the diagram show. Pocket spaces at communal area allow cross ventilation throughout the building. Every floor was cascade 1 meter from each level to increase the efficiency of the photovoltaic panel, as the diagram shows. Pocket spaces at communal area allow cross ventilation throughout the building. Moving to the third objective is to implement passive design strategies in order to reduce energy demand in the building. First is the courtyard. Courtyard, which provide balanced illumination across the building, reduce contrast and provide high level of diffuse daylighting on the center of the courtyard. Self-shaded form. Self-shaded strategy provides shading without obstruction of natural ventilation and natural lighting. The form eventually helps to reduce the heat gains and maximizing diffuse daylighting. Green facade. Green facade helps to reduce direct solar patch into the building. Third, pocket spaces. Pocket spaces allow cross ventilation throughout the whole block. And last but not least, sustainable material. Most of the material used was raw materials such as steel that can be recycled, timber features, bare concrete, etc., as it shows the honesty of the material itself. Lastly, here are some walkthrough videos I would like to share. Enjoy!